Alright, how do we handle these square roots, these radical numbers? How do we simplify this stuff? Here's all these problems we're going to do here. So if anything up here looks unfamiliar to you, we'll work it out right now. We can figure this out. The most basic sense. What are we doing here? You're trying to simplify this square root number without using a decimal. To do that, you need the list of perfect squares up here. You look at this and you think, is 12 divisible by any of these perfect squares? We pick one out. It's 4. 12 is the same as 4 times 3. We know the square root of 4 is 2, so that's going to come outside the square root. But that 3 is left inside the square root. There is our answer. We say this is an exact answer in math because it avoids any type of decimal, any irrational number that has some kind of decimal that doesn't have a pattern and doesn't repeat. That's what we're trying to avoid. Common mistakes, things like this. People say, wait, what about 2 times 6? Isn't that 12? And it certainly is, but I don't see 2 on this list up here, and I don't see 6. So the square root of 2 times 6, well, you didn't do anything wrong here, but it's not any closer to the answer either. What if there's a variable, like the square root of x to the 7th power? It might be useful to imagine this as how many factors of x? 1, 2, 3, 4, 5, 6, 7 factors of x. What's a square root really doing? It's asking us what number times itself is whatever's under that square root. That means for every pair of variables we see, the square root is one of those variables. So it works kind of like this. We'll take this square root sign and we'll think about what's left inside and what's outside. For every pair you count, one factor of x comes to the outside. So I see 1, 2, 3 pairs of variables. So 1, 2, 3 factors of x come to the outside. What's left on the inside? One factor of x. I would never leave it like this, of course. We know that x times x times x is x to the 3rd power. X to the 3rd root x is our answer here. Now, some people know some better ways to do this. Some people think, hey, I can just imagine that square root of x to the 7th, instead of splitting into all its factors, I will split out the even factor, x to the 6th times x, or x to the 1st. Then, you know, anytime you take the square root of an even exponent, you just take the half of that exponent, x to the 3rd square root of x. Both of these methods do the same thing. The second one is a little bit more advanced for people who really understand it. But hey, if it helps you, write out however many factors of x there are and circle the pairs. All of that comes outside, and you've got your answer. How do we handle with multiplying square root numbers? Well, square root of 3 times the square root of 15 is the square root of 45. I just did 3 times 15, right? But we would never leave this as the answer. We always want to see, is the number 45 divisible by one of my perfect squares up there? It certainly is. 45 is 9 times 5. And what do we know the square root of? We know the square root of 9. The square root of 9 is 3. That comes outside the square root. 5 is left inside. Our answer, we would say, is 3 root 5. What if there's more stuff under here? What if there's variables like this? How do we do this? One part at a time. 2 times 10 is 20. And then when you're multiplying exponents or variables with exponents, you're basically counting up how many factors you see. 1 factor here, 3 factors here. 1 plus 3, x to the 4th. So what do we know the square root of under here? Do we know the square root of 20? No, it's not on this list, but it's divisible by something on that list. 20 is 4 times 5. And x to the 4th is an even exponent, so I'm just going to leave that right there. You think, what do I know the square root of? I know the square root of 4, and I know the square root of any even exponent. Square root of 4 is 2. Square root of x to the 4th, we just take half that exponent, x squared. Only thing I don't know the square root of is that 5 left under the square root sign. 2x squared root 5. Crazy looking answer, but it follows all the rules of simplifying radicals. If there was a number outside, we would multiply that too. So like this example, we see nothing to the outside of the square root sign except that negative, so that's just kind of like a -1 there. So we're going to keep that outside. So on the outside, negative sign. On the inside, let's multiply. 6 times 10 is 60. How about for x? Let's count up how many factors we have. 1 here, 3 there, that's x to the 4th. For y, y to the 2nd, y to the 4th, we count them all up, 2 plus 4, that's y to the 6th power. What are we looking for next? We're looking for factors of 60 that are on this list. You might have to grab a calculator and just check a few of them. Some calculators may do this for you, but we need to see the middle step to make sure we're thinking and the calculator isn't doing all of our thinking for us. So keep that negative sign out there. 60 is divisible by 4. 4 times 15. How do I know that? We'll just grab a calculator and start guessing. 60 divisible by 9? No. It's divisible by 16? No. Eventually you're going to guess a 4. X to the 4th, y to the 6th. What do we know the square root of here? Let's circle it all. 4. And I know the square root of any even exponent. We just cut it in half. So let's take a look. On the outside, I will have my negative sign, which stays out there. Square root of 4 is 2. X to the 4th, square root of x squared. Square root of x to the 6th, or y to the 6th, is y to the 3rd. Anything left inside the square root sign? Positive 15. There's our answer. We need to be good at this stuff. This should get us through the first worksheet, the first part of this. But this is the type of math that we really need to learn well. We can't forget it.